Today's topic, side-loaded and top-loaded beams. Why connection details are extremely important. Good morning and welcome back to our shop. So today I want to discuss a little bit about floors and how either a dropped beam, which would be considered a top-loaded beam, or a flush beam, which would be considered a side-loaded beam, how they interact and the application of connection details and why they're so important. So what I have before you is just a small mock-up of a floor system, and right now I have the floor joist spread at 16 inches on center with a top-loaded beam. So this would be considered a uniformly loaded system where all the weight across the top of the beam is the same. We don't have any point loads. We don't have any loads that are connecting into the beam anywhere else than the floor joist. Typical application like this, what you would have is per our TJ 4000 or our framers installation guide, beams like this that are multi-ply, 2 and 3 ply, all the way up to a 4 ply, which would make a 7-inch wide beam, typically can be done with nails, either a 10D or 16D nail, 12D as well, and there's nailing patterns that would go with that. In a top-loaded beam, the connection detail is more about holding the beam together so that as weight is applied, the beams don't want to separate or flare out from each other. Right now, I have the beams independent. They are not actually nailed together at all, but you can see with the weight that's applied to here that they're working in unison. If I was to lift the weight off of these, everything is going to go up together, everything is going to come back down together. Let's take a look and see what happens when we move the system into a face-loaded or a side-loaded application. Or taking each floor joist and installing it into the hanger on the opposite side. The connection details become even more important as to how a beam is assembled, for the simple reason that you have multiple plies, and these plies need to work together in order to carry these offset loads. Again, it's a uniform load from one side that is being transferred through the outside ply and needs to follow through into the additional plies. So now that these are all hung into their respective joist hangers, if you take a look at the bottom of the beam, notice how the inside beam, which is considered the face ply on this, has deflected or has moved out of position. We have almost 1.5 inches. Obviously this is a mock-up, so it wouldn't look as severe as this. We would see more of a deflection issue, not everything dropping out, because of course they would be supported underneath on both ends. But what we're trying to look at and explain here is nails are not always the solution. You have to have a certain amount of shear capability in the fastener that's holding everything together. So what happens in a multi-ply beam that's going to be loaded from the front or from the back? If we have, let's say, 500 pounds per linear foot on the back span and 700 on the front span, each of those face plies, as we expand out, is going to be carrying a different amount of load that has to transfer and make that beam work in unison. So it becomes extremely important that once nails no longer can hold that weight because they don't have the high enough shear capability, we're going to be moving to a structural type screw or moving into through bolts. So at the end of the day, it's very, very important for these types of connections. And where it becomes even more critical is if you start to add point loads to this. That takes everything out of the realm, because now you're stressing and putting a lot more weight at an individual point, which can need a different detail that is going to show a different bolting pattern around that joist hanger possibly. When it comes to side-loaded beams, we can still refer back to our literature. However, it's going to be more critical that we take a look at these applications in either Forte Web or Javelin. Through those software systems, we are going to be able to take a look at how the loading is applied and determine the proper fastening material, as well as the on-center spacing or the staggering for the different thicknesses and plies. Remember, as we gain in thickness, fasteners are attaching through all of the plies if there's extreme loading on one side, but there will still be possible cases that we have nailing applications that may work. Again, always consult with your territory manager or Weyerhaeuser engineer as we move into a side-loaded beam. So you're probably asking yourself, well, I don't want to have to put all those nails in. I don't want to have to read a pattern. I need to send the beam right to the guys, get it done. So what can I do to make this as easy as possible for an installation, whether it's going to be a top-loaded or a side-loaded beam? One of the great things about Weyerhaeuser is our ability to make multiple types of materials for similar applications. So if you're not using a Microllam LVL in a multi-ply application because you don't want to have to worry about relying on the connection details, we can move up to a single-ply member, Parallam PSL. It is going to be a parallel strand lumber in the same sizes as Microllam, but it's going to be a 1-unit beam, all the way out to 7 inches in thickness. By doing this, we've completely removed the connection details of holding plies together, and we don't have any issues with whether this beam is going to be top-loaded or side-loaded. With that said, if you guys have any, or girls, have any other questions or comments on how this can be done, make sure you leave a comment in the section below, hit that like button and subscribe to our channel, and we'll have a few more of these videos coming back out over the next few weeks. And again, as always, Steve Radowski with Trust Joist Weyerhaeuser. Safety, we're going to practice it, we're going to preach it, and then we're going to go do our job. We'll see you on the next one.